explain a couple of things, so listen real close. First thing, you're going to take this quiz. This quiz should take you about 7-8 minutes, and that's all I'm going to give you. All right? I will explain more about the quiz here in just a minute. Other thing, have your homework, page 92, laying out on your desk. I'm going to walk around and check it while you are doing your quiz. Does everybody understand those two things so far? Now, once I get this quiz up here, work on it. You can work on it with a partner. I don't want you moving all around the room doing, I don't want it to be a headache, because if it starts to be a headache and everybody's loud and obnoxious and crazy, then I'll say, all right, time to turn your quiz in. But you can ask your neighbors, you can ask your partners for help. If it gets too loud, then again, I'll tell you to turn it in. When you get finished with your quiz, I'll have you lay it on the blue chair up there. We'll go on from there. We'll go over the homework, and we'll start doing stuff.
Are those going to be put in the grade book before? Are these, like, is this supposed to be put in
the quiz
before?
Problem. Yeah, good question. These quizzes will probably go into the grades before the end of the 9 weeks. So, along with this homework, the notebooks are in there. Anything we do this week, I will probably... So like tonight's homework too, since what I've heard, Friday is a white day, tonight's homework will be on this 9 weeks also. So if you're looking for grades to try to bring your grade up or something, then that would be helpful. I will answer questions here in a second. On the quiz, I can talk over this. On the quiz, up here. Listen carefully, because we're going to do quite a few quizzes this way, and hopefully I explain it this one time, then next time you won't have to sit and listen to me give this explanation again. We'll do OGT quizzes periodically throughout the year. If you look in the front of your book, there's a section that's OGT section, and at the top of each page it's got like week 15, week 16. Well, we don't want to be that far ahead. We're starting with like week 2 back here. So what you're going to do, you're going to look at those pages, go to week 2, find question 2. That's the first question on the quiz. Week 3, question 1. Week 4, questions 2, 6, and 7. And then there's a bonus question, week 4, number 3. So, does everybody understand how to find this? It's right in the front of the book. It tells week up at the top. Just do that certain problem. I just picked problems off of a week here or there because of stuff that we've covered here lately or that we're covering right now. Does that make sense to everybody? All right. So you should be working on that quiz. Have page 92 laying out. When you're done with the quiz, lay it on the blue chair. You can work with a partner. Help each other. One of the problems, I can't remember which one, might be like this second one here, so I can't remember, might be number 2 there. One of them asks you to draw something. Am I going to take all points for your artistry? Absolutely not. All right? So draw it to your best of your ability. If it's anywhere close, you probably get credit for the drawing. Now they also ask you to give a number for that problem. So it actually has 2 answers, the drawing and the number. So make sure you do that. Somebody had a question while I'm trying to remember what the other thing was that I need to say. Did I answer it? Whoever had their hand up a minute ago. Oh, I know what the other thing I need to say. I've seen some of you using your tablets. These questions are on the book that's on the tablets, but I need to get back in there and rename it. I downloaded the book and I renamed everything, and then I had to download the book a second time, and I was upset and I forgot to go back and change everything. But if you get on the book, it's one of the top ones that says standards. So if you're trying to use your tablet, it's on there, it says standards. So start on that. Again, have your page 92 laying out. I will come around and check it here in just a minute as soon as I get attendance and stuff done.
Can you play the music? It's actually like that song.
Sorry. You sure it's the song that you're thinking?
I don't know. Is it Michael Jackson?
I don't know. Everybody else, I'll say it all the same time. Don't waste a whole lot of time talking about other things other than this quiz, because we'll not have time to get finished. And Elena come in tardy and go home early. Michael Wilkinson, Brianna, Jonathan, Skyler, Emily, Travis, Lavender, Kayla, Jacob, Dylan, Emily, Yes, this is Jack. This is Michael right there anyway. All right, thank you very much. That's second. Again, that page 92 laying out there so I can check it. Your grade's messed up. That means that everybody else's grade in that class is messed up. I forgot to check one. do tonight, page 92. And show me next time, show me what's going on. Just took me a second to look.
No, 60, and that's, if you have a, no, your percentage is, right, if you have 65, you have to, 64 is below 50. That's all.
Okay, so good.
Okay. Yeah.
The one that the answer was got any other answers up there, Shelby?
I'm on number 2.
Probably gonna have to go back. All right, what I want you to do, watch carefully, follow along, have your books open because I don't have a book. So have your books open to week 2, number 2, then number 3, or week 3, number 1, so on, so on, so on. Week 2, number 2, and I've seen these problems several times, so all you have to do is refresh my memory a little bit. What's week 2, number 2? How's it start out?
What is the difference between point A and C?
So you're on a number line, right? From A to C. How do you find the length of a segment if you're on a number line? Do you have to use the distance formula? No, what do you do? Count. What did it come out to be?
4.5.
I think it was 4.5. Why did Bronwyn say 9? That's how many spaces there are, but each space only counts as a half. So 4.5 was the answer to the first one. Week 3, number 1, which one is it?
The drawing one.
The one with the drawing? So this is, because you know how my artistry is, so this is how I would start this one. I wouldn't even draw it first thing. I would do this, stage 1. How many dots did stage 1 have? 1. Stage 2 had how many? 5. Stage 3? Stage 4? 22? Stage 5 is what we're looking for, right? They want that number. Well, then you need to look at the pattern and try to figure out the pattern. How much did that go up by?
4.
Plus 4. How about that one? Plus 7. How about that one?
10.
Plus 10. Anybody have any idea what the next one's going to go up by?
13.
Plus 13. So what's that number?
35.
That's one of our answers. Now, the reason I wouldn't have drawn it first, is because of what Bronwyn just said. She counted wrong. If you drew it first and then you tried to count the dots, is there a good chance you're going to count it wrong? Yeah. So if you go through and you find the pattern first, then worry about counting it. Now, how am I going to draw this? What's the easiest possible way to probably draw this? Start off with just one side. How many sides is the fifth stage going to, or how many dots is the fifth stage going to have on each side? 5. So I'm going to do this. That's my bottom. It's got 5 dots on it. How many dots should this side have on it? You guys have seen my drawings in the past. They're usually not good.
5.
All right? So I put 5 dots there. How many should this side have on it?
5.
How about this side? And this last side? Is that pretty good? It's not bad for my normal stuff. Now, if you thought, okay, they want me to draw everything, then all you do not too bad. Week 4, number 2. Number 2 on week 4, what's it say?
According to the Venn diagram, how many students in the sophomore class at high school have a dog, a cat, or both?
Read that last 4 words again.
A dog, a cat, a dog.
What's the key word there? Or. What's that tell us? All right, if it says or, is it all right to have just a dog? Is it all right to have just a cat? If it would have said and, would it have been all right to have just a dog? Remember, when it's and, it's got to be true for both halves for the whole thing to be true. When it's or, true for one or the other, and the whole thing's still true. All right? So what did you have to do on that one?
Count.
Sort of add them all up. So what'd you come up with?
244.
244? Everybody agree with that? Should have been the answer. Number 6. What?
Isn't that also within the dog and the cat? Because
Now, what'd you just say? You said dog. You said dog and cat. What's it say? Dog or cat.
okay, but
There's a difference.
There's a difference. Dog or cat means you could have a dog and you still count. You could have a cat and you still count. When you say dog and cat, you gotta have both.
33 is when they do have both, so.
But it doesn't say and in it. If it would have said and, then you would be correct. Since it said or, that's a completely different thing. All right, so you got to be real careful. What's number 6 say?
What is the approximate distance between points R and T?
To find the distance between 2 points on a coordinate system, what do you have to use? Distance formula, not the midpoint formula. Distance formula. This is the distance formula again. Please don't forget it. We'll use it over and over and over throughout the year. Somebody help me out for R and T. We need to know the coordinates. What's the coordinates of R? Negative 4, 2. Go ahead, Travis, please. Negative 4, 2. What's T? 3, negative 2. Everybody agree with that? Those both right? I plug them in here. What's my X coordinates this time? What's my Y coordinates? What's going to happen there with the 2, negative 2? Negative 4 minus 3 is negative 7. Negative 7 squared, be careful. Positive 49. 2 plus 2 is 4. 4 squared, 16. To help Brianna out here, when you get to this point, if you have any negative numbers, then put your calculator down and use your brain. All right? Because your calculator is lying to you. Negative 7 squared is not negative 49. If you get to this point and you have any negative numbers left in there, something's not right. All right? You did something wrong. Go back and figure it out. Add those together, you get 65. Is 65 a perfect square number? No. But what number, because I don't have a calculator and I don't feel like walking and getting one because I'm lazy, what perfect square number is close to 65? 64. What is the square root of 64? 8. So we know our answer, 64, the square root of 64 is 8. Our answer should be bigger than 8. Look at your choices there on the page. Is there only one of them that's bigger than 8? Yeah, 8.1. Number 7, what's number 7 say?
Michael's little brother built the tower shown below. Michael's counted that there were 110 blocks left on the floor. Following the same pattern, how many layers could the tower have been built?
Now again, a lot of people are having trouble with this. First thing I would do, first level. How many blocks on the first level? 2. Second level, how many blocks? 6. Third level. Should we be able to figure out the 4th, 5th, 6th, 7th level from that pattern? Now, some people said that they see it better this way. The first level was 1 by 2, wasn't it? 1 block by 2 blocks. What's the second level? 2 by 3. What's the third level? What's the fourth level going to be then? 4 by 5. So how many blocks is it going to have? 20. How about the fifth level? 5 by 6. How many blocks is it going to have? What's the next one going to be? 6 by 7. 42. Seventh level, which is good. Next one, which is. Now I'm not going to go out any farther. I probably went out too far already, I think, because how many total blocks does this young man still have to use? So he's got 110 blocks. He was right here. He's still got 110 blocks laying out there. Does he have enough for the fourth level? Does he have enough for the fifth level? How many total has he got so far? 50. 20 and 30 is 50. Does he have enough for the sixth level? How many total we got right now? 92. Is he going to have enough for the seventh level? So how many levels could he have built? Could have built 6 levels. The last one, I can't remember why I made this a bonus, because it was probably like the easiest one on the whole quiz. They tell us angle 1 was what, 30 degrees? What's angle 3 then? How come it's 30? Vertical angles, very good. Vertical angles. What do you know about angle 1 and angle 2? Other one. They're adjacent and they're supplementary. What do you know about supplementary angles? So if this is 30, what's this one?
150.
What's angle 4 then? 150. What did they ask you to find? Angle 4 plus angle 2, right?
Yeah.
Which is how much? Was that somebody who just put down angle 4 or angle 2 without
180.
doing the end? All right, on the homework. So open up your books to page 92. Questions, problems you want to see worked off of page 92. Probably ain't going to work on that. Problems you want to see worked off of page 92.
No.
23. Problem 23.
Pardon me, just interruption. Zach Green to the office, please. Zach Green to the office, please.
Line XB lies in plane K. Is that a K or an X?
That's okay.
Okay. So problem 23. Line, what is it, XB?
Yeah.
One of the postulates or theorems that were on those pages, and we're going to go over them here in a second again, because I don't think I went over them well enough last time, so I'm going to run through them real quick. If I got a point X here, Michaela, hold your fist up in the air for me. Michaela's got a point B there. We connect them. How many lines are going to connect those 2 points? There's one line in this world that could connect those two. Now, not only is there one line, but that line, if there's some plane, some flat surface that runs between me and Michaela that contains my point X and her point B, is that whole line going to be in that plane also? Yeah, and that's what it is. So, what did it say? I think it said they wanted to tell you whether it was true or false or something. And then it wanted you to give a reason.
No, it just says state the
Give a false.
Okay, so it's true, and the postulate or theorem is if 2 points are in a plane, then the line containing those 2 points is in the plane. Alright, so again, watch carefully, I'll show you up here. If I put point A right there, point B right there, both those points are in what plane? What's the plane that I consider? The whiteboard. So they're both on the whiteboard. Alright? If I draw the line that goes through those 2 points, which there's only one in the world that goes through those 2 points, if I draw the line that goes through those 2, is it going to be sticking out here like this? That whole line is going to be on the what? The whiteboard also. That's all that postulate says. If 2 points are on the plane, then the whole line that goes through those 2 points are on that plane. Sort of common sense, right, Allison? If I draw a point here and a point here, the line that contains both those points isn't going to come out this way, is it? It's going to go right like that. Next question.
Can we go over postulates a little bit?
Yeah, we're going to go over them here in a second. Other questions? What is this? Is what the base
I'm not going to. I'm trying.
He said no.
Okay, got it.
So if you go back and you watch this video of me taping this, you can be sitting at home watching the video. You can be scared there too. Thanks.
Awful.
It's horrible.
Is the 16th? Go ahead and start copying this down. If you weren't happy with your binder score, can you fix it? Yeah. Is it going to be, all you got to do, start today. This is new 9 weeks for as far as your notes. Keep the notes right there in the binder every single time.
The binders is easier to.
Thank you.
I just can take this on.
Yep, you can. You don't have to take everything out of your binder. As a matter of fact, I would highly suggest that you don't take everything out of your binder and start all over, because when you do that and you go to study for your Chapter 2 test, you're going to have half the stuff in one binder, half the stuff in another binder.
What time Tyler is next?
Oh, I didn't put a title on them, did I?
Be able to.
If you want the title, Algebra Proofs. Algebra Proofs. Not sure why. I forget to put a title on these sometimes. Alright, so what we're going to cover today, we're going to start writing. When you get to this point right here, write this in. A formal proof is also called a 2-column proof. A formal proof is also called a 2-column proof. Last time we talked about paragraph proofs. They were also called what? Instead of formal, what were they? Informal. A formal proof is a 2-column proof. It's sort of backwards to what English would consider it. In English, you're done writing your paper when it's in paragraph form, right? A 2-column proof is like your rough draft or your outline. So it's a little different from English. It's like backwards. Whoever made up the names apparently didn't like English very well, so they didn't want to go the same way as English. A 2-column proof. Why do you think it's called a 2-column proof? It's got 2 columns. That's real hard. Math people real ingenious as far as the names they make up. Like a triangle. Why is a triangle called a triangle? It's got 3 angles. Triangle. Why is a quadrilateral called a quadrilateral? It's got 4 sides.
Why is a square called square?
Squares. John Square named that one. So see, we can't. He was one of those stupid math people that.
Okay. Circle, I guess, too.
Yeah, John Circle named the circle. All right, these are the properties that we're going to cover. You covered these properties last year in algebra? Yep. You went over them, then you probably forgot all about them once you started solving equations, because you went over them and your teacher said, all right, you do this each time because of this property. And then after that, you just did that each time because your teacher told you to.
You want to leave space in between.
Yeah, not really. Ethan ought to especially remember these because we actually took tests over these. We had a test that you had where Ethan had to match up the property to a problem that used the property. Because a lot of people didn't do so well on it, and we actually took it twice. All right, reflexive property. Reflexive property, and we're going to use, you might put some asterisks beside reflexive property, because later on in the year we're going to use it a whole bunch. Reflexive property is really important in geometry class. Reflexive property says A equals A. Well, that's what it says in algebra. In geometry, it actually says anything equals itself. All right? So angle A would have to equal angle A. Segment AB would equal segment AB. And again, I know that sounds silly, but later on in the year, you'll be happy whenever you see reflexive property, because that's an easy step to do in some of the stuff that we're going to do later. So reflexive property, anything equals itself. Symmetric property, a lot of you, when you're solving equations, use symmetric property at the end every single time, because you end up with this answer, 5 equals x. And then you write down what on your paper? X equals 5. You turn it around. That's using the symmetric property. Did you ever do that when you solved equations last year? Always turn it around? Yes, you did, Travis. All right, probably most all of you do, because we get used to seeing x first, or the variable first, so you just turn it around. That's symmetric property. Transitive property. We talked about a law the other day. Which law goes along with transitive property? This is a property you guys couldn't remember when I asked you about it the other day. Syllogism. All right? The syllogism law. It's sort of the same idea. It's a little different because you're dealing with different kinds of things. But the transitive property says if A equals B and B equals C, then you know A has to equal C. That's the transitive property. All of these, you might want to jot this out to the side. All of these are properties of equality. Why are they called properties of equality?
Because they equal something.
Exactly. All of them have a equal sign in them somewhere. Properties of equality all have equal signs in them. The next one's here. Addition property of equality. What did they do to go from A equals B to this right here? Added what? C to both sides, right? So all the addition property says is it's okay in an equation if you add the same thing to both sides. You knew that, right? Because last year when you were solving this, how did you solve that equation? You added 2 on both sides, right? What you used right there? The addition property. That's what you were doing. And your teacher taught you the addition property and then showed you how to use it. And then did you ever think about the addition property again? No, you just did the math. Okay? But what you were doing every time you did something like this was the addition property. You were using the addition property. You add the same thing to both sides. What do you think the subtraction property is then?
Same thing. Subtraction.
Subtract something from both sides. So if I subtract 5 on this side, what do I got to do on the other side? Subtract 5. Multiplication property, what do you think it is?
You gotta multiply it on both sides.
Multiply both sides by the same thing. Why is there not a what?
Division.
I don't know. Why do you think there's not a division property?
You can't divide on both sides.
Yeah, you can.
Just guessing.
Why do you think there's not one? Anybody have a good reason why there's not a division property up here?
Just something they come up
Wait, what do you do?
with. Same as the other
Just
one.
multiply both sides by the same thing? Come on, so one of you guys gotta be smart enough to know why there's not a division property up here.
Cricket.
Wow.
You gonna tell us?
No, I'm gonna show you. Because it's on the next slide, there wasn't room for it. Goodness. Do not write this bottom thing down here. I'm just going to explain it so that you don't have to mess with it. Division property. Division property, just do what? Divide both sides of the equal sign by the same thing. Substitution property. You remember what substitution is? Where you substitute one thing for another. So if I tell you this rag and this marker are the same, wherever I see this rag, I should be able to put what in its place? This marker. All right? Yes,
Is
Dick.
the wording right on the substitution property?
Yep.
Did a may be replaced?
Now, what Jacob is thinking here, and I'll probably go back after today and change this slide because I never even thought about it that way. Substitution property. If A equals B,
Oh, alright.
then the letter A, so I should have probably used something like P. If P equals Q, then P may be replaced anywhere that you see Q. All right? So maybe I should have thought about it instead of the word A. Distributed property. Everybody knows what distributed property is, correct?
Yeah.
Now, this bottom part down here, what it was supposed to be, watch carefully on this. I'm going to actually do it this way. What would I do first to solve that equation?
What was this?
X plus 5 plus 2 equals 8.
Combine like terms.
You would collect like terms. All right? So, if I was going to collect like terms, trying to,
Forgot to get the
You know, it usually stays there.
Yeah, that's what that is.
So if I got x plus 5 plus 2 equals 8. First thing, collect those two together, I get x plus 7 equals 8. Did I use the addition property there? Why not? It wasn't on both sides. All I did right there, everybody watch so you don't miss this, because I know there's some on the next test that we're going to take. If you're just collecting like terms on one side, I didn't do addition property, I just did addition. All I did there was addition. Now how would I solve that?
Subtract.
Subtract 7 here, subtract 7 here.
What you're gonna do, you're gonna divide more.
Now, what's that step? What did I use to get from here to there?
Subtract.
Subtraction property. Be careful when you're using subtraction property. How come I didn't just write SUB? Because I'm lazy and I normally wouldn't write anything out. It might be substitution. So make sure you write at least subtract. Don't just write subtract either, because that's wrong. Subtract property. Alright? So make sure you can tell the difference between addition property, subtraction property, multiplication property, so on, so on, so on. Alright, a 2-column proof we already talked about is a formal proof. Write this down. We're going to do this 2-column proof. You're going to have it right there in your notes. And then we're going to do another one after this. No, it's different. It's different. Yeah, that's just splitting up the two things. Make sure you write these down. Now, the reason that we're actually doing this, the reason that I am doing algebra stuff in here is because when we do the geometrical proofs, you're not going to like them. So I'm hoping to ease you into them a little bit, because you know how to solve that equation? Yeah. So we're going to do something that you already know how to do and put it with something new that you're trying to learn. It's not the same as the way I showed you last year. I'm going to show you. If you see a 2-column proof in the book, it'll look like this. It'll say given, right? Then it'll say prove. And then it'll have something down here. This one will say something like this. X equals whatever X comes out to be. So any 2-column proof, anytime you see something that's written like this in the book, that tells you you're supposed to write a 2-column proof. It'll say given. Well, this time there's only one piece of given information. That's the equation. Next time, if it's a geometrical proof, it may say angle A is congruent to angle B. Angle B is congruent to angle C. Segment AB is congruent to segment QR. It may tell you 10 different given information. All right? But it'll look like this. Given, proved. Normally with that, in a geometrical problem, you're going to draw the picture, come out here and start doing stuff. So maybe you draw some picture. Maybe that's your picture this time, and you say, all right, I know this angle is equal to that angle. I know that this side is equal to that side. Mark everything that you know in the picture and think it through, just like an English paper. When you start your English papers, do you start off, in this paper, is that the way you start an English paper? No, first thing you should do, and a lot of teachers make you do it now, first thing they ask you to turn in is a what? Johnny, we had this discussion the other day. First thing that they make you turn in is a what? An outline, and then maybe a rough draft, so that you have to go through the proper steps to get to it. instead of thinking, oh, the night before I'm just going to sit down and I'm just going to write it out. It doesn't work very well. These proofs aren't going to work very well if you just all of a sudden come over here and start trying to write the proof. Now with the algebra proof, since you already know how to solve this, it's not that big a deal. All right? But I guarantee if you do this on a geometry proof, what I'm doing right now, making this little drawing, I'm going to yell at you. All right? Because you should go out here and think it all out first, then worry about coming in here and actually writing it. Okay? So you should make sort of a rough draft, then write your answer. Now on the algebra proof, it's not that big a deal. Why do you think these are called two-column proofs? There's two columns. The first column, statements. Second column, reasons. So draw that. Statements, reasons. What do you think your first statement's going to be? Keep going. You're going to start. Remember when you were writing a paragraph proof, you got to start somewhere, right? That's where we start at. What we're given. How did we know that 5x plus 3x minus 2 equals 7x plus 8? They told it to us. Now what you're going to write here, you're not going to write, they told it to us. You're just going to write given. You're going to learn to love given statements because they're easy. Nothing, you don't have to do anything. How did I know this? Oh, it was given to me. Any other time, a reason over here, be a property, a definition, a theorem, a postulate, something along those lines. All right? Every reason. Now, in an algebra proof, unlike last year in algebra class, if you were in my class and you didn't show your work, -4 and just go on, right? I just take all the points away and you get nothing. So in here, I don't want you to show your work. What's the first thing we would do there? 8x. And that's what you write down here. 8x minus 2. So instead of showing your work in between there, you just say, all right, I went from this step to this step. You could stick it in there and I won't throw a big fit. All right, so just make sure showing your work here is not a statement. All right, so if you put something in between here, like on the next one, maybe you put a.
Could we just do it on the side then?
Yeah, you could do that. So you could come out here and do it, and then transfer it over there. That would work. Now your reasons. This is where your properties are going to
Yeah, I
go.
was about to say, would that be the addition property?
Exactly. What? Now be careful. What did we do there to get from this statement to this? Just addition. Why not addition properties? We didn't do anything to both sides. So it's just addition. If you put collect like terms or combine like terms there, I would accept that also. Still a rule. What's our next statement going to be? What? Okay, go ahead.
1x minus 2 plus 8 equals 8.
How did we go from this statement to this one? How did Ethan go from here to there? What did he do? He minus 7x on both sides. So what property is that? Subtraction property. Again, can I just write this?
Yeah.
What am I going to write? Subtract, subtraction, property. Notice all you're doing here, got a statement, you give a reason for that statement. Got a statement, you give a reason for it. You're proving this as you
Do
go
we
down
have
to
to
it.
put property for addition too?
Now, up here, do we have to put property? Why not? We didn't add on both sides. Remember the properties, so when you do something to both sides. Here, we just collected those together. All right? Now what do we do? X equals 10.
Yeah.
How did we get from here to there?
Addition property.
Addition,
Will there ever be like say
property.
do one and like, will there be like two subtraction properties?
There could be. Yeah, it could be, could be 5 subtraction properties, depending on how the problem is set up and everything. Do we need to go any farther? How do you know when to stop? When you get to whatever it is you're trying to prove, that's when you're done. So if you go farther than that, you're doing more work than you have to do. You shouldn't have, right? You're trying to prove that. What X is, hey, we just did it, we're done. All a 2-column proof is, give a statement, you give a reason. Give a statement, you give a reason. The book, don't let this confuse you, I forgot to mention this, the book letters theirs, so they'll say like A here and A there, B here, B there. Don't do that, use numbers. They do it for like this chapter and next chapter. Then in chapter 5, they quit doing it and they start using numbers. I don't know why. Just to confuse you, I guess. It doesn't hurt anything if you put like A, B, and C, but it's just easier to use numbers. Now make sure you're numbering these, because this statement number 1 has to go with what? Reason number 1. Statement number 2 goes with reason number 2.
Could we put what, like, X equals 10, would we go to improvement, but 10 on that?
You don't have to. This right here, this whole thing is your answer. All right? So whoever looks at this next, the whole purpose of a proof, just like an English paper, whole purpose of an English paper is to get something across to that next person that's reading it, right? Whole purpose of this proof, if anybody looks at this proof for this algebra problem, should they know how to solve that problem? Yeah. You explained it to them out, each statement, each step, and what each reason was behind each step. All right, do this one. What I want you to do, try this one on your paper there. We got about 8 minutes. I want you to go ahead and try it. This is the given information. I'm going to give you about 3 minutes to try it. We're trying to prove this time what X equals. Keep forgetting to use my other pen. So this is given. This is what we're trying to prove. It says 3 parentheses 2x minus 5 parentheses plus 12 equals 48. Go ahead and try to do that, and we're going to figure out what X is. I'm going to go ahead and, again, I just told you never ever to do this, but I'm going to. So know that we're going to run out of time at some point. Statements, reasons.
Do we need to keep writing statement and reason?
Yeah, you can put like an S and an R maybe. Yeah, I won't be, a big jerk about stuff like that. Everybody should be trying it right now on your paper. If you can't get the first statement and the first reason, what kind of person are you?
An idiot.
Notice, did Mr. Eversole say any of those silly words that I didn't say not a one of them?
You were thinking.
No, don't tell me what I was thinking. You're not a psychic, Travis. If you were a psychic, then you'd never miss any problems on any of my tests. If you know them all beforehand.
I just want to make sure you don't think I'm super smart.
Is that what it is?
Yeah.
All right. So you don't want to show that you're a psychic, huh? Everybody that believes that, raise their hand. You believe it too?
No, I don't know.
Oh.
I don't know.
I thought you had one fan, Travis. Yep, but what did you do? So do it. No, you got to do this, otherwise you got nothing.
Mr. Average.
Yep.
So like, single you can't do that, you're gonna potentially do this. But what about a plus 12? Because that's minus.
And you just write it down. Remember, that's why you're going step by step. What's our first statement going to be? Our first statement's going to be given?
First statement's gonna be 3, parentheses, 2x, minus 5, parentheses, plus 12. Equals 48.
I didn't give myself enough space. Now, what's our reason for that statement? That was given. Again, we said, hold on, let me rephrase that. You guys said, if you couldn't do that first one, what's the first thing you do to start to solve that? Distribute, right?
3x,
So what is it?
3x, 5x,
No, it'd be
6x. 6x, my bad.
6x?
minus 15 plus 12 equals 48. Distribute.
So what property did we use there to get from this to this?
Distributed.
Distributive property. Again, if you abbreviate some of these, I don't have any trouble with that. Now, what do you do next?
Combine.
Combine, be careful,
Like negative 15.
negative 15 and positive 12. What's that going to leave us with?
Negative 3.
Before that, 6x minus 3, good.
Equals 48.
Be careful here.
And subtract.
Okay, now, if you wrote subtract, do I need to put the property on the end?
No.
Now, the other thing, Johnny's looking crazy back here saying, you didn't subtract, you added. Could you have written addition there? Yeah. You could have written collect like terms. Is there any difference between adding and subtracting? You're not even supposed to think about addition, subtraction anymore. You're supposed to think about combining like terms because this isn't a minus 15. This tells you that 15 is what? Negative. Tells you that 12 is what? Positive. So if you wrote subtraction, addition, collect like terms, whatever, then I would accept any of those. Ah, you stupid thing. Number 4. What's the fourth step?
You add the addition property. You add 3.
So what do you end up with? 6x equals 51. She said addition property. Now what? So what's the next one going to say? X equals 51 divided by 6. What did we use there? Division, just division. Is that what I write? Just division? Division property.
You don't actually know what S is.
We just did.
I know, but it's not.
Now, if you wanted to change it to a decimal, you could. If you wanted to just reduce it down and make it 17 over 2, that would be okay also. Your assignment. Your assignment's on page 97. No. Page 97, 14 through 28, 30, 37, 38. Laid on my pink chair.
I know. You will fly.
Right there, yeah.
I don't know. I meant sleep. In sleep, you will fly.
Lay it on my chair. So, Michaela. Not asleep. I'm gonna say all the way. Now I am. Keep your hands out of your pocket. Is what, Michaela? When you're set, listen to me, because otherwise I will start checking you. I will start checking you every single day when you walk through my door.
Sitting like this?
See, you're not supposed to, hey, Ethan, you're not supposed to. Ethan.
I'm not that.
But Michaela, I will check you every single day.
Yeah. Yeah.
You don't know how bad that hurts. I know how bad. Oh, that's why I'm cold.
Hey, Brittany. No, stop. Keep quiet. Hey, Brittany. Stop.
Sounds good. I'm hoping he was right. Never ever tried again. Yep. Yeah, 'cause I did a bunch of stuff with her. All the time. See you tomorrow.